After completion of these two measurements on the left side and right side, this is the final tabular form. Okay, number of the ring. The final value of the left side values will be noted down here, and the right side values will be noted down here on the particular columns. And after that, the difference of these two, left side value and the right side value, will give us the diameter of this particular number of the rings. Or suppose this one will be 12.054 minus 11.802, 0.252 is the diameter of the second number of the ring. Now we need to square this value, 63504. Like that for second, 12.1085 minus 11.7565, 0.352. Again we need to square it this value, 0.352, 0.12394. Answer is R equals to Tm whole square minus dn whole square divided by 4p lambda.
Okay, here the R is radius of curvature.
R is the radius of curvature. Dm and dn are the number of the rings which we are going to consider. You can choose any two number of the rings out of these three, like 2, 4 are the two rings, or 2, 6 or 4 and 6. You can choose. And p is the difference of this one, and lambda is the wavelength of the light source which we are using.
So the lambda will be constant. Okay.
It is constant. Whatever the light we are using, that is 5893 Armstrongs. We need to convert this into centimeters. 5893 into 10 to the power of minus 8 centimeters. Since all minus d2 square divided by 4 into difference of 4 minus 2. P is equals to m minus n. That is equals to 4 minus 2. That is 2. The higher ring will be the m. The lower ring will be the n. The difference of these two numerical values.
Okay, so ring number 4 will be subtracted from 2.
2. 4 minus 2, only this value.
Okay.
Not the diameters, the numerical values of the rings only. 4 minus 2, 2. 2 into this one, wavelength 5893 into 10 to the power of minus 8. Like, what is the value here? 0.12394. We have already did the squaring here, that's why we are directly taking the values. 0.123904 minus 0.063504 divided by 8 into 5893. Here we will take this one upward under the power of 8. You can direct 8 into 5893 is 47144. 0.123904 minus 0.063504. 0.06 divided by 0.0604 divided by 47144. 47144. You are getting 128.118 centimeters. Here this value is 1.281 something into 10 to the power of 8. Very long values. After multiplying this value to, we are getting 128.118 centimeters. Our actual value of the radius of curvature is 100 centimeter. This is original value, actual value. This is actual value, and we are getting 128 centimeter, or 28% error. If we repeat for 4 and 6th ring and 2 and 6th ring, then we can take the average of all the three. We can minimize the error, percentage error.
See you in the next video.